So welcome back. In this video, we're going to see the first project in deep learning, and the name of a project is a potato leaf disease. So, what is exactly a potato leaf disease? First of all, we'll discuss our problem statement. So, our problem statement is farmer every year face economical losses in a crop waste due to the various disease in potato or tomato plant. First, problems or disease are early blights, late blights, and these are the major disease in potato leaves. Around 10 type of disease appear in potato leaves. So it estimate that the major loss occur in potato yield is due to this disease. The image are classified into three classes. So first, I have imported a pill library from a image library. So by using that, I open the three images. First is a early early bleed is this type of disease we showed in the image. Then we have a healthy leaves. These are the image of healthy leaves, and we have a late bleeds, which are this type of images. So I have shown the three images, which shows one is healthy and two is early and late bleeds, which is the type of disease happen in a potato. So we have to find out uh, those images or those pictures by using the CNN model. We develop here a convolutional neural network by using by using that model. We are identify is that image or is that leaf is uh, having a disease or not, or a healthy image or not. So for that, we have actually a three category. You can see we have healthy, late, and early bleed. Bleed. So we have three categories. So for that, we will use a softmax as a activation function. By using that uh, categories, we have three categories, more than two. If we have a two, then we might use a softmax. Sorry, sigmoid. But we have a three. For that, we will use a softmax. First of all, we'll do first thing as we create a directory. It look like you are trying to create we are trying to create a directory, a name of kaggle in your home directory. We are creating in a home directory. So for that, what we have, we command a command as a mkdir command used to create a directory on the specific name. Slash p is a flag ensure that the command does not produce any error. If it produce the error, it will not reflect there. Okay, if the directory exists in our home directory, then it will not produce any error. Okay, so we'll pass this, and after that we have a this command is nothing but a command of copying the file. Which file? So for that, we need to go to the Kaggle and download our API. So you need to go there and generate your API. Go to the setting on a Kaggle and generate your API. So once you have done that, so what we are trying to do here, uh, we are trying to copy the file name kaggle.json to the directory of Kaggle directory in your home directory, in our home directory. So cp is the command used for copying that file. Okay, after that, what we are trying to do, we need to go to the kaggle, and those we have the file of a data set. So what we are trying to do, we are trying to try to do here is downloading those file, like a data set file. So uh, after using this command, what we are trying to do, we are trying to kaggle this command interact with kaggle API. By using this kaggle name, we are interacting with kaggle API from the command line using the command line prompt. Then download dataset download is this sub command used to download the dataset from Kaggle. Then we need to provide the -d. This flag indicate that you are trying to specify the dataset you want to download. Okay, D means you want to download that. Okay, and then after that, this is the unique identifier which is given into a data set. So go to the data set, you can go and download that by using this uh, unique identifier. Once you click that, it will start downloading your file. So I'll go and try to copy that file once. So let's run this. You can see here your Kaggle API key is not readable. Okay, I need to fix that. That's why I am going to just. So you can see here I have used the change mode 600 root kaggle json. Because of this, I'm able to read my file. So I have the zip file of potato disease leaf now. After that, I'll just run this zip file from zip file. This is for that we are able to read that zip file and extract all the data from that zip file. So once I have done that, you can see that dataset has been extracted. So I'll just ls. So I'll get I have early as a, this is the image, healthy and late, these are the image. Then I have a list of the file I have in my directory. So kaggle.json I have. Then this is the sample data. Then I have the zip file. So I have able to read that zip file and extract it into a pld slash tree classes 256. After that, what I have done, I'll imported all the important libraries which are needed in further program. So you can see matplotlib, seaborn, keras. Then I have pandas. From keras model, I'm using the sequential. Then from keras layers, I'm using the dense because we need as in cnn model. Then we have a convolution 2D. Then I have max pooling, flatten, dropout. Then we have a in from keras dot pre-processing image, we have image data generator because we are going to generate our data also. Then we have a sklearn model dot selection train state split from imported TensorFlow as a TF. Then we have a CV2 and OS. After doing that, what I have done, I'm trying to रीड दैट डेटा. सो हम यहाँ पे अपना जो कुछ भी डेटा है, वी हैव लाइक थ्री फाइल्स लाइक ट्रेनिंग, टेस्ट डेटा, एंड वी हैव लाइक validation data. So I am trying to read training data. I have given the training data as a data name from TF as a TensorFlow keras dot preprocessing image dataset from a directory. This is the a function we are using, and we are passing our path of a training data. After that, we are using the hyperparameter called shuffle is equal to true. Then we have the data, whatever the data we have, it try to shuffle that data. You can see that uh, shuffle that data. Then we have a image size of 256 by 256, whatever the image size we have in that folder. But what it will do, it will resize that image size into a 256 by 256 and create the batch size of uh, batch, batch size of 32. So that's the thing. So uh, in this code, what we have created TensorFlow image dataset, name, data by loading the image path, and we are shuffling that image and resizing that image into 256 by 256 pixel and group into a batch of 32 images per batch. The dataset is now used for a training the model. After that, we have the validation data. Same, we have using the tf.keras preprocessing dot image dataset from the dictionary. We have given the path, we have given the image size and the batch size. Same for the testing data. We have created that. So I'll just go and run this one. So you can see that we found a 3251 file belonging to three classes, because we have three classes. After that, we have a validation data and we have the uh, testing data. So as per what we have done, we have used a like um, 70 to 80% of data for uh, for training, and 10% of data, around 10 to 20% of data for validation and for testing. After that, we are going to get the classes. So data dot class names, so I'll get my class names. If you can see here, I have early blights, healthy, and late blights. So blights and a disease or spot on the leaf. So after that, what I am trying to do, I'm trying to get my data, like this code, this code is likely to give the retrieve the data from a first batch of the image and label of a TensorFlow image data name as a data. So what we are trying to do here, by using this code, we are fetching the first batch from the tensor image of a data, okay, by using the method called taken. So we get our first batch of first image. You can see that the specification are 256 by 256 and channel is 3, because it is a colored image. And you can see the data type. Okay, after that we'll go, and what I'm trying to do, I'm trying to get the 3 by 3 or a tensor for my first image, the in the form of array. So by using that, I'm getting my for I use the for loop for I in data taken and print the I. So I get that into a 256 in the in the array of 256 by 256 in the channel of 3, and we have 32 total. What number of batch is batch for 32. So you can see that. So okay, after doing that, I'll get my array, and you can see that after getting, I'll go so you can see that this is the again I use one uh, for loop for image slash batch labels slash batch in data taken. Okay, so I'll get my first batch, and I'll get the image batch shape is like 32 batch number. This is you can see this is 32 is a batch number. In first batch we have 32, like uh, एक batch 32 का है. After that we have 256 by 256 and three channel. So these are the 32 uh, uh, what we say batch labels. Okay, after that I'm trying to get the I'll just run this one. Let's see. Yeah, it run. And after that, I'll try to get my first image. So you can see that, you can see this is the first image of my uh, okay. in batch 1 image size. After that, I'll go and I'll try to retrieve my 32 images from first batch. So what I have done here, I'll use my plt.figure, and I have given the size of figure as fixed size of 10 by 15. For loop I have used, and I'm trying to get my 32 first batch. Then I have used the subplot. If you multiply 8 into 4, I'll get a 32. If you enter a subplot with ununique number, means not if I want to get a 16 images, so what I have used in for loop for I in range of 16, and I'll get 4 by 4, so I'll get 4 by 4, 4 rows and 4 columns. What right now what I'm getting 8 column and 4 rows. And after that I use the I plus 1, because I need to get all the images of 32 from first batch. After that I use the plt dot im show and image batch I numpy a is type uint, and then I've given the title is equal to class name of label batch, and I pass the I. So if I use this, let's try that what I'm getting. Okay, so I'm getting this first is healthy. You can see that. Can you match this one? This is the first. This is first, because if I write 0, I'll get this one. Okay, now I'll go further. The length of data is, you can see, I'll just pass. I'll get my length of data. You can see 102 uh, length of data. So now what I am trying to do, so we have to resize and rescale the images, because our images is in the form of 256 by 256, and I want those image into a scale image like 0 and 1. So in this code what I'm using, resize and rescale model is in a sequence to pre-processing layer. What we are using to pre-processing here, first one, first layer is resizing the image 256 by 256 resize, but our image is already in the form of 256 by 256. But if in case it's not in the 256 by 256, then what we are doing, we are resizing that image. After that, resize input of target size of 256 by 256 pixel, and after that what we are doing in second layer, rescaling that image in the form of 0.1 and 2, by scaling the pixel value of the image by dividing them by 256 by 256. This operation convert the pixel value from 0 to 255 range to 0 to 1 range respective normalized image. So after doing that, in first step we are doing resizing and rescaling in the form of 0 and 1. If you see the array taken, data dot taken 1, it's in the form of 0 to 256. Now our data will be in the form of zeros and ones. Okay, uh, so we'll move further. Now we have a data augmentation. Why we use the data augmentation? You can see data.aug, tf.keras sequential, and for that we have used the layers dot experimental pre-processing random flip. So what we are trying to do, we are flipping the image, and we are diversitying our data set. So by using that model, we have a two data augmentation layer. First layer is random flip. By using that, we are passing the horizontal and vertical, randomly flip the image vertically and horizontally. And in second layer, whatever what we are trying to do, we are randomly rotating that by zero point 0.3. So image will be range of minus zero point 0.3 to zero point 0.3 radian. This data augmentation technique are useful to increase the diversity of a training data and improve the generalization of machine learning model. So what we are using, so by using the data augmentation, our model will not uh, uh, means overfit. Okay, I'm passing that. After passing that, did we pass that? Yeah. Yes, both. After that, we are creating the model sequence. So I use uh, this code initialize the empty sequence of model. Okay, and model allow to add the layer one after another sequence, forming the linear stack of a layer to build a neural network architecture. You can add a different layer such as convolutional, then dense layer, which are fully connected, then activation layer, uh, to this model to be structured as a neural network. So after that, what I have done, I have added our rescale and resize model dot add. After that, what I have done, model dot add data augmentation. So data augmentation will be happen in the first step only. After that, what we have done, we have added the model dot add model dot add and convolutional convo 2 convolutional layer 2 2D. It is in the 2D form because we are using the image, and it will the so what I have done here, I'll just show you. Here is, we are using the 32 filter, and the kernel size is 3 by 3. Our activation function is relu, and input size is 256 by 256, and three channel 32 of batch. This is, we have passed, this is the input shape of our image. So in this code, we have added the 2D convolutional layer to the model with a 32 filter as a kernel means filter, each of having the kernel size of 3 by 3. The activation function we have used is a relu, rectified linear unit activation function. Then we have a input shape parameter which is said to be 32 as a batch size 256 by 256 image of a pixel, and 3 is a our channel. So this is a typically used in initialing the feature extraction from the image in CNN based architecture. This layer basically used for feature extraction. If you are trying to extract the edges, if you are trying to get uh, like, if we want to get the edges or a specific area or location from a image, we are getting the feature from by using this layer. After that, what we have done, model dot add, we are using the max pooling. If you don't know about what is max pooling, average pooling, sum pooling, or anything related to a CNN model, then go and watch my CNN related video. I have added over there, I have explained very simply, so you can go and watch that. In max pooling, what we are doing, we are getting the max of the the feature map, whatever the like, we have given the 2 by 2 matrix like 4 8 8 4. So what I'll get the 8 because of max pooling. 8 is the maximum value from that 2 by 2 matrix. So this is the simple way to explain the max pooling. Okay, now in this max pooling, what we are doing, the code to get the add of max pooling. Okay, and the pooling size of 2 by 2. This layer in pooling, what we do, we perform the downsampling of a feature map and obtain the previous convolutional layer by reducing the spatial dimension by factor of 2 in the both height and width. Max pooling take the maximum value within the 2 by 2 window and discard the other value, as I mentioned before, effectively reducing the size of a future feature map while retaining the most important feature. Max pooling help reduce the number of parameter in the model and introduce some translation invariance, making the model more robust and small translation into the input data. So इसका कहने का मतलब क्या है, we are using the max 2 by 2 window. So we get पुलिंग, मैक्स पुलिंग का काम क्या है, डाउन सैम्पलिंग करना. पुलिंग का काम ही क्या है, डाउन सैम्पलिंग करना, इमेज को कॉम्प्रेस करना. बट by compressing that image also get the important feature from that. That's the use of max pooling. After that we are adding the convolutional 2D layer of a 64 filter with a kernel size of 3 by 3 and activation of a ReLU function. I have created whole architecture over here in Jamboard. I'm going to explain that after the completion of this video, or this after getting our result. So after that, what I have done, I have added again a max pool 2D 2 by 2. After that, I have added again the 2D layer for 64. I know it is very complex. I have created little complex, not very complex, little complex model, because especially when we create a model, we create with a very small, like a not very complex model. So I have created a complex model that it will be explainable, because we can use the VGG or ResNet, or uh, uh, there are different model we can use. But image also we have, for ImageNet we can use different model, but here I'm using the customized model. Okay, and you can see after that we have done the flattening. What is flattening? The flattening layer of the model, this layer used to convert the 2D, जो भी हमारा इमेज का जो 2D में है उसको हम 1D वेक्टर में कन्वर्ट करने का काम कर रहे हैं, बाय यूजिंग द flatten layer, multi-dimensional representation into a single continuous matrix, which then pass by the input of a subsequent fully connected layer. Flatten is a necessary to translation from convolutional part to the neural network fully connected part, where a traditional dense layer are used for classification and regression. So what we are doing now the flattening that 2D layer into 1D layer to get that we can use for that fully connected layer. Uh, so after that, what I have used here, dense of 64. So we are getting the 64 neuron, and we are using the activation function of ReLU. After that, I'm getting the 3 class. Length of a class, we have a 3 class. So I'm using the dense of a 3 and activation of softmax, because we have a multi-class classification. So that's why I'm using the softmax, and we have a 3 classes. After that, model.build, I use the model.build and I pass the input shape. So uh, model.build is nothing but this set of architecture is neural network based to provide the input shape, and method is typically used when defining the custom layer of model in Keras. Here it appear to be used the set of input and entire model. Okay. After that we are using the summary, so we'll get our summary from the model. Including the layer name, we are getting what we are getting layer name, type of layer we are using, like sequential C7, sequential 7, convolutional 2D 8. Then we have a total number of layer, then we have total output shape, what we have output shape, then we have a parameters we have train over here, like total parameter is like a 8 like 96,323. So if you want to calculate that, you can calculate by this adding this. And if you want to know how this parameter are generated, you can go and watch my CNN video, so you will know that. But for example, if we have a 256 by 256 image, then you must have a question of how it become the 254 by 254. The formula is like n m minus n plus 1. So my m is 256, my n is 3, because we have a 3 by 3 filter,
and plus 1. If I minus 3 from here, 253 plus 1 is equal to 254.
This is the 254. If you want to know how this formula is generated, or from where I got this formula, you can go and watch the CNN video. You may have clear, or you will get all the thing clear over there. So I'll just what I'll do, I'll just go here, I'll just run all of this. Okay, now you can see the reason is simple. Why I'm not getting this? There must be reason, na? Okay, I'll try to do that. LA Baba. Okay, one, two, now three, four, five, six. अब देखते हैं. Yeah, it passed that. Now we have done the flattening. Then we have a ReLU. Then we have a softmax. Then we have our build. Then we have a summary. After summary, we have the model dot compilation. So by using this compilation, we are using the optimizer is Adam for gradient descent optimizer. The loss function we are using is training for training is spare categorical cross entropy, because we have more than uh, three category. And after that we have additionally using the matrix to evaluate. Matrix is accuracy. This means that model accuracy will be compute and displayed during the training to track the performance of a training data. Accuracy is a common matrix used for classification task to measure how many prediction of a model got correct compared to the actual value. So this is the use of accuracy, and why we use the spare categorical entropy. Okay, after compiling, we are going to do the model fitting. So what I have given the data, then batch size, validation of data, and verbose is equal to 1 and epochs is equal to 50. So by using this model, we are using the data set of data, because we have stored in our data with the batch size of 32 sample per batch. The validation data is v data.val is used for validation during the training. The training progress and matrix are displayed during the training. The model is trained for 50 epochs. That means it will go through the entire training data set by 50 times during the training. And fit method is used to optimize the data parameter based on the provided data. Okay, so I'll just run that. We'll see. Once it's completed, it may take a little more time to train. So for that, what I have done, we will go to our Jamboard and I'll show you कि हमने यहाँ क्या किया है. So we have the image of 256 by 256 into 3, because we have a colored image. After that we have the 3 by 3 filter. So we'll get a 254 by 254 image size, and you can see that. After that we have a max pooling 2 by 2. It become 227 by 227. And then we are using the filter 3 by 3. Then we have a max pooling. If you want to know how this calculation coming, you need to go and watch my CNN video, because we have the formula for that. By using that, we calculate mm, uh, the size of image. By and we have the same, I have created here a same model which we use in our program. After that we have a 3 by 3 model. Again max pooling, we have a filter max pooling. We have a filter of 30, 64, 64 and 64. First is 32. Then we have a three filter, a filter size of 64 by 3 times, and max pooling. After max pooling, by using this layer, what we are getting the feature extraction. Again we have the, then what we do the flattening of 2D layer into 1D layer. We get the flattening. After that we have a hidden layer. This is the input as a flattening. Then we have like around 12,500 something. If I go here and if I try to, I know it is going to take much more time. So but I'm going to stop video after that. But I have to show you, like you can see flattening. How many neuron I'm training for first layer is 12,554. So here I'm getting the total number of input are 12,544. So I'm training that by using the hidden layer. In second the second layer is 64, so I'm getting the 64 here. I'm training that hidden layer and output as a 3. So you can see this is the output layer: early bright, healthy, and late bright. This is the classification. So I have created full network, you can see here. Okay. uh, After that, here you can see this is the training process. It will take a little longer time. You can see here the losses. We have the loss of 1 and accuracy of zero point 0.4 for first layer. It will going to run for 50 time on our data set. So I'm going to go and pause this video for a little bit time, and once it is fully fit, I'll come back and I'll continue. Okay, just give me okay, back again. As you see, we have completed our 50 epochs, and we get, if you see the score dot model dot evaluation, after doing the evaluation and I passed the data, testing data, and I got the score of loss of 0.04 and the accuracy of 0.98. So 98% of accuracy I'm getting. And I have just stored the, if you want that accuracies to be stored into a variable, so you just need to take that result. If this is the variable result dot history, from history we need accuracy, uh, validation accuracy, then from loss and loss, validation loss we store into a variable. After storing that into a variable, we try to do the plotting. Plot dot figure, ld dot figure, figure size 10 by 10. We have two like subplots, like you can see first one is the accuracy and second one is loss, accuracy and accuracy, validation accuracy, and training and validation loss, training loss and validation loss. So we have taken that first is first plot is about accuracy and second plot is about losses. So what we have done, we passed the epoch range of 50, from you can see that 0 to 50. And on x-axis we have like on y-axis we have like uh, training accuracy from point 0 to point 1. And yeah, that's the thing we have passed over here. You can see accuracy and validation accuracy on one first plot, and we have given the label. You can see that training accuracy and validation accuracy. So training accuracy and validation accuracy, uh, the legend of IO, Al, IOS, LOC, a lower right, uh, and then we have given the title. Same, we have plot the training validation loss. Okay, after doing that, we have imported NumPy, and what we have done, we have taken the first batch. From first batch, we have image and label name, and then we store into a first image and first label, and then we try to show. If you see, this one is the first image, and we try to predict the, by using this image, we predict the what type of disease or is it healthy or not. So after predicting the first image, we get the early blights. So this is, you can see the prediction is accurate. After what we have done, we created one function called prediction. Predicted, we pass the model and image. So you can see that image dot array t tensorflow dot keras pre-processing image to array. We have converted that image to array, and what we have done, image dot array is expanded. We have expanded our dimension of array
image we have given the image array and a zeroth on zeroth index. Okay, then we try to predict the model, predict dot model, and we have passed our image array. So we pass the array into a model dot predict, and prediction is stored into a predictions. After what we have done, prediction dot class, we get the class name is equal to argmax. Whatever the prediction is, the argmax is numpy dot argmax is give the maximum of the prediction of zeroth index. After getting that, we store into a confidence round into 100%. We store into percentage argmax prediction into a 2 into form of how much prediction is corrected. So we have stored that into a confidence. You can see that the confidence is 99%. So actual and what we have done here, we passed the first image, and then we tried the first batch, and we try to get the first 9 images. We pass and we try to plot into 3 by 3. You can see 3 by 3. uh, and I am sure that I pass, we get a numpy of array, then we pass that into a model and image. We have given that over here. You can see predicted class and confidence, confidence kitna percent hai, we have passed over here. You can see that. And after that, actual class, and uh, this is predicted class, this is actual class. You can see that, and we have a confidence, how much percent of confidence we have, and then the axis of. So you can see here, actually it is light blight and predicted light blight, and we get the confidence of 94%. Here you can see it is a healthy, and we predicted as a healthy, and the confidence level is 98%, 98.91% with 99%. Here you can see the healthy and 99%, 100% getting the accuracy. So you can predict. Now you can use the OpenCV, and you can use your camera and show the leaf image, and it will try to predict, by using that model you can predict it is healthy or not. So this is the our model. We have predicted very careful, means we predicted. Even I show how we draw our model in Jamboard also. You can go and watch that. If you have not watched my CNN video, ANN video, go watch that. I have created differentiation, and in CNN I have explained all pulling, strider, and all of this. If you got this video very clearly, if you have any doubt, comment down below, or you can mail me in my mail address. Like, share, and subscribe. You can add this project in your resume also. Thanks for watching this, and share with your friend. Okay.